Hello everyone, welcome to today's movie. In today's movie we're going to look at a simple time series data set, and we're going to use a simple exponential smoothing model to fit a model to the data and then use that model to provide a forecast. Now remember, this is exponential smoothing, so we just forecast for one time period ahead. And in this particular movie we'll use Excel. In another movie later on, we'll be using SPSS to solve the same problem. So if we go to Excel, and as you can see, the model's provided on the screen, and this problem is data that's been collected in 1960 to 2018, which is concerned with the UK birth rate per 1,000 people. So in 1960, the UK birth rate was 17.5 per 1,000 people. In 1961, it was 17.9 per 1,000 people. And in 2018, it was 11 per 1,000 people. So you can see that the birth rate has dropped since 1960 to 2018. Okay. Now, what we're going to do is that when you're solving this type of problem, if you so wish, and then I'll just take that off, is to plot the series first. So if I highlight the data series, and then what I can do is I can click on Insert, I can click on the line graph, and I'll choose the first option. So that's what the data series looks like over time. And obviously, you can put the chart titles in at a later date, etc. The vertical axis is your series value, and the horizontal axis is your time point. So you can see how the birth rate, the UK birth rate per 1,000 people has changed since 1960 to 2018. Okay, so what we want to do is we want to fit a model, a simple exponential smoothing model, to this data set. So you can see that at time point 1, my series value is 17.5, and for simple exponential smoothing we use this equation here. Now you can see that if I have time point 1, t equal to 1, then this term would be t minus 1, which would be 1 minus 1, which is 0, which we don't have. So what we have to do is we have to set an initial value for S1 dash, and we fix S1 dash, which is that value there, equal to the series value for that time point. Now please note, SPSS uses a slightly different method, and I think if I remember correctly, what it does, it averages across the data series to give you your first value. Okay, but we're going to use this method. So the initial starting value for S1 dash is equal to Y1. And then we use this equation to get S2 dash, which is alpha times Y2 plus 1 minus alpha, all times by S1 dash. Remember, T is 2. Okay, we know S1 dash is that. We know alpha is that. So the equation is that times that plus 1 minus that multiplied by that to give us 17.86. So the simple exponential smoothing model, smoothing constant value would be for time point 1, 17.5, for time point 2 it would be 17.86. Now what we can do now is we can get all the other smoothing values for all the other time points by copying and dragging and copying this formula down. But remember, we need to fix alpha. Okay, so we use $J, $2. There we are. And then there we have to use $J, $2, etc. And then once we've done that, we can then copy the formulas down to there. So the last value is the smoothing value at time point 59, which corresponds to 2018, is 11.0441. Okay, so the seasonal simple exponential smoothing model fit is 11.0441, and the actual value seen was 11. Okay, now when we want to use that model to provide a forecast for the next time point, and that's what we do. So you can see here that the first forecast value would be at time point 2, and the forecast value at time point 2, F2, would equal to S1 dash. So it's that is equal to that. Then the next time point, that forecast, which is time point 3, look, time point 3, that value is equal to that value. And then you can just copy the formulas down, as you can see there. Now, because this is a forecast fit, we can then drag that down to there to give us the forecast at that time point, because that value is just equal to that. But we can't extend it any further, please note. Now, once you've done that, then if you were to click on there and click on there and then copy, and then we can right click on the graph and paste, and there's our model fit. So the blue line represents the original data series. The red line represents the simple exponential smoothing model forecast fit. Okay? And then remember, you can see here that we've got one time point into the future, and that's why that red point is there. Now, at this stage, if you wanted to continue the analysis, then you can use the idea of fitting a prediction interval to our series. Okay, SPSS does that fairly easily, and we'll look at that in the next movie. But if you look at the linear regression movies, or you go to the book, then the explanation of how to fit a prediction interval is actually there. Okay, so bye for now.